Okay, we've looked at the idea of projection and sort of developed the formula for projection. And we've seen that projecting V equals 3, 1 onto W equals 2, negative 1 appears to come really close. The projection line appears to come really close to the tip of W. But this is a sketch, so no reason to think that that would be exactly the case, so I didn't draw it that way. However, when we got this formula and ran the numbers, which I ran in my head, we're going to check that in a minute, but when you run the numbers, you find that the projection is just the vector W, so really this projection line should have hit the tip of the W vector. Anyhow, let's verify that and demonstrate the whole process. Okay, projecting V onto W, the vectors that we were seeing earlier. Here's the expression we got for the projection. We multiply this expression, which you recall was V magnitude of V cosine theta, by this, which is a unit vector, vector of length 1, in the direction of W. Often you'll see this formula where the two magnitude of W expressions are combined to give you magnitude of W squared. And in my opinion, that's a terrible way to do it if you're trying to teach people about meanings. This is your magnitude of V cosine theta. This is your unit vector in the direction of W. If you combine these two magnitude of W expressions, you get the magnitude of W squared, which is algebraically correct. You totally obscure the fact that you've got a unit vector times your V cosine theta. Okay, so I prefer to do it this way, and I'll even emphasize that. Here, the magnitude of V cosine theta is this part of the expression. And this part of the expression is your unit vector in the direction of W. In any case, calculations are easy. V dot W, and when we do a dot product, I've introduced it by saying put this as a row vector and multiply by this column vector. So we have 3 times 2 and 1 times negative 1. You know then that we're just going to match up the first number with the first number of V with the first number of W, second number of V with the second number of W, and then we're going to multiply those, and then we're going to add the results. Okay, so at this point we just say, okay, well, the dot product is this times this plus this times this. We don't have to switch this over into a row, so we can multiply it by the column. Still, it's important to understand that it's the same thing. Okay, we get the same result. Okay, so V dot W is 5. 3 times 3 is 6, 1 times negative 1 is negative 1, 6 and negative 1 is 5. Magnitude of W, Pythagorean theorem, 2 squared and negative 1 squared, it gives us 4 plus 1, which is 5, so we have the square root of 5. And then we have W over the magnitude of W, which is square root of 5. Well, 5 over the square root of 5 times square root of 5 is 5 over 5, which is 1. That's our W vector, which is 2, negative 1. So, it's as I said. Now, who would have thought? Okay. Since that projection worked out the way it did, let's just do the projection of W onto V. So projection onto V of W. And of course that equals W dot V course, W dot V is the same as V dot W. Doesn't matter in which order you do the multiplications of the first numbers and the second numbers, okay? And the magnitude of V is square root of 3 squared plus 1 squared is the square root of 10. And then that's going to be times V over the square root of 10. Well, I could have done W dot V, and really I probably should have. Yeah, let me back up and write this out. We've established that the magnitude of V is the square root of 10, but since I'm not doing any substitution in these expressions at this point, it would have been better to write out the entire expression. Okay, remember, since we're projecting onto V, it's got to be magnitude of V here. V over magnitude of V, because we're going to get a vector parallel to V, or in the direction of V or opposite, and so forth. Okay, now we can do the calculations. W dot V, 2 times 3 is 6, negative 1 times 1 is negative 1, that's 5, just like before. And the magnitude of V is the square root of 10. So we have that. So when we multiply the two square roots of 10 out, we get 5 over 10, which is 1/2 V. Now again, I wouldn't have predicted that it was going to come out exactly 1/2. And picturing this, remember we've got V here, W here. Haven't drawn them. Yeah, let me draw them a little more accurately. It looked a little better than it came out when I was looking at it from this angle. But let's go ahead and sketch a set of coordinate axes. Mark off 1, 2, 3 units, and 1 unit here and 1 unit here. And 2, negative 1 puts us about here. 3, 1 puts us about here. So here's V, here's W. Our projection line comes back perpendicular to V. So here's our right angle. So geometrically our projection is this. And that's pretty close to 1/2 of V. The way I drew it, if it was done with a very accurate drawing, it would be 1/2 of V. Okay. So that's maybe a little more than you want to know about projection, but projection is a very important operation. We want to understand it for sure geometrically. We want to see how to construct the thing geometrically, and then here's a way to calculate it using the dot product. Dot product being just like a row times a column.